So my name is Fredrik Jansson. I work as a solutions architect in the BD team, and I have with me
Simon. I work as a developer, responsible for most of the packages, so the HCC, PMP, NFVO, and the resource manager.
So we thought that we'd talk about this. So John asked us to talk about PMP and NFVO, and it turns out we have this beautiful product called VBranch that actually marries these two, that uses both PMP and the NFVO stuff. So we're going to use that as the driver for this speech. So very briefly, what is VBranch? We have all these fantastic acronyms, ENCS, the Enterprise Networking Computing System. It's a small hardware that you send out. It's an x86 hardware. On that, you're going to be running NFVIS, the NFV infrastructure software. We have function packs. Anyone knows what a function pack is? It's a package or more packages running in NSO that we as a BU support. So we have a VBranch function pack, and on top of the VBranch function pack, we have the Ione function pack, for example. And the idea with these virtual branch offices is that you take standardish, I call them standardish hardware, because for example, the ENCS is x86 hardware, but it does have some hardware in it I totally lost the word. To increase network performance. And the idea is you send these out to your customers instead of a hardware router, and you actually run your router on this. So it's used as a small data center. So you're going to run your ISR router in there, maybe a firewall as well, on the customer premises. So this is what we're going to use as a demo today. So I just thought I'd walk you through what we're going to do. And so in this, when you take one of these boxes to your office, you plug it in. What's going to happen is going to use PMP to call home to NSO. After that, you can actually use the NFVO package or NFVO function pack to start up these virtual machines on it. For example, the ISR router, an ASA firewall, WSA, for example. And when they are up and running, you can actually start provisioning day 1 and day N configuration on these virtual machines running on the customer premises. So with that, over to you.
Okay, so this will be quite technical. I'll go through the PMP protocol on a low level. So first of all, what is the PMP protocol? It's a call home protocol, basically giving you a zero-touch network automation installation of your device. So you plug in your device and it will automatically, semi-automatically call home to a server that provides its day zero configuration, its initial configuration. It's an open solution, meaning that the schema are publicly available. Anyone can go and read them and see what it does. It's written by Cisco, and it's only us that implements it. So there's no IETF or standards organization behind it, which is that's too bad. But so that means there's a schema, but there's no real explanation on the functionality. There are bits and pieces of documentation out there, but yeah, okay. So I'll go through. So what what we provide is the PMP server, or an implementation of a PMP server. So first I'll go through how a PMP agent, a device out there, actually discovers how to communicate, how to find the PMP server. So it goes through a bunch of steps to try to figure out which PMP server it should talk to. First, it will use DHCP, and if that's configured using the option string, I think it's 60 and 43 with the IP of the PMP server, it will use that. If that's a no-go, it will try to use DNS. If that's a no-go, it will use the Cisco Cloud Redirect Service, which is basically a service that Cisco have somewhere where the customer can go in and name the serial of their PMP agent and point it to a PMP server somehow. And the fourth option is that it's pre-configured. So we call it the -1 configuration of the device, that the device already knows which PMP server to talk to, or you go in manually, as we will do, or have done in the demo for that device. So you just specify the IP address. Okay, so the PMP server, that's what we are doing. It's a function pack. And as Fredrik instructed you on what a function pack is, VBranch is a function pack which consists of other function packs, so it's a recursive thing. And the meaning there is that it's supported. It's something we sell and support, we support the PMP version 0.1. I think that's the only version out there, so that's what we support. And we do a subset of what our PMP servers are supposed to do. We provide day zero configuration. There are also parts that we don't do yet, such as provide software image upgrades. This might come in the future. We do that, plus we integrate it with NSO, the device manager of NSO. So after a PMP, the agent has called us, we will add it to the device tree, so you can start provide day end configuration to the device. So this picture shows one scenario where you have a PMP client or agent which will communicate with our PMP server. We will give it a day zero configuration and then we can manage it. I'll go into the details later. This is a bit more complex situation where you have a firewall. And I just wanted to illustrate that in that way the PMP client will still contact us, and we will provide day zero configurations which will provide an IPsec tunnel or something, so we can still manage and contact the device. Right, and our PMP server only talks HTTP. We haven't implemented the XMPP support yet, and it's not in the roadmap to do so, unless there are public demands for it. All the communication is driven from the PMP agent itself. We only react to HTTP GET and POST requests. We never initiate the contact, the communication with the device. There are 3 queries that the PMP agent can do towards the server. The first is the hello query. It's an HTTP GET method call that it does to the server just to see if it can reach the server. It does that once. Then there's the work request. Basically, it asks the PMP server if we have any work for it to do. That could be apply day zero configuration, or that's mainly what it is. And then there's the response for the work request. So it sends a work request, we give it some work, and it responds with how that went. And okay, so these are the 3 responses for these requests that we provide. So for the hello, we just give a 200 OK if it can reach us. If it's a work request, we will either send it work, or we will tell the device to back off and come back in a configured amount of time. So come back in 5 minutes and check again, or 5 days and check again. And then the work response, we just simply acknowledge that we got the result of the device, and we say bye. And then that communication flow is done. This is a more detailed picture of how this loop works. you'll see that the PMP agent in the beginning will initiate a GET request towards us, and we send a 200 OK. We will then right, and so, yeah, okay, so this picture has the PMP agent, and both these parts are NSO. This is the PMP server part, and this is the device management of NSO. So you also see the internal communication within NSO here. So once a device communicates us, we create an internal state of that device to keep track of the device. Then the device will, number 3, there is it will send an info. That's actually the work request. It will ask if we have any work for it to do, and we will ask for its device info. Basically, yeah. So we ask the device to give me all the information on who you are. And that is anything from software version to ID to yeah, all possible information the device has. And then we store that information internally as well. And then we say bye. We're done with you for now. Then the device will come back again in step number 9 there and ask for work, and we will provide it with a day 0 configuration. You see that number 10, the arrow that goes to itself, is that you can either point to a day 0 file, and in that file you could have variables that you need to substitute depending on which device it is. And then we send that configuration back to the device. It responds, and we then mark the device as being configured, and we say bye. It will then contact us again, and then we will actually add the device to NSO and do a sync from, and then tell it to back off. And then you see the loop step here. That's the device, unless we in our day 0 configuration tells it to turn off the PMP protocol, it will keep contacting us for new work, and we will keep telling it to back off until you reconfigure PMP server to actually do something more. Feel free to ask questions whenever you have any. Yep, Larry.
Some kind of identification there, and say that all messages that tells it that it's a device that we're looking for.
So not in the initial hello. That's just can I reach you. Then you will configure your PMP server with the serial of the device, and if we don't have that serial in our configuration, we will mark it as a device that we haven't claimed. It's an unclaimed device, but we'll still keep track of it. We'll still answer its reply. We'll just say back off if we don't intend to manage it. I'll go through the security here a bit as well. As I said, we use the HTTP protocol. On top, or the PMP is using the HTTP protocol, so then of course we could use the security of HTTP, which is using an SSL tunnel. Then there's something called SUDI, a secured unique identifier, device identifier, and that's on the actual PMP level. I have a slide here, which, okay, so this slide shows a scenario where in the beginning the device will contact us on the non-secure HTTP. We will tell it to install a certificate and contact us again on HTTPS on a different port or server or address. And then we will initiate a HTTPS tunnel session using, yeah, question?
Sorry. Did you hear that?
No. I did, but the camera did not. So.
Okay, so when you contact the server the first time for the device, does it authenticate in any way, or how do you know that the device that is trying to reach you is? Are you expecting this device? Do you have like a inventory of serial numbers? Something like that. Right.
So that's, and we'll show you that in the demo. So that's where you have your, the device will contact us with a serial number. It's serial number, and if we don't have that in our configuration, we won't respond to it. We'll just say back off. So that's Right, but not. So Ione here said that we also have client certificates and stuff, and that you don't have in the first steps here, and that's a kind of an unsecure way where we tell it to install this certificate and contact us again if you want to verify us. But if you want to be real secure, you should have a certificate already on the device that can verify the server, and the server should have a certificate that can verify the device on HTTPS level.
Okay, thanks. Oh, and I still have that.
Yep.
So the device object on NSO is created in step 4, right? And then it's just being updated along the way.
Yep.
Okay, thanks.
So the top thing is don't do it that way. It's possible to do it that way, but the recommended way is of course to use HTTPS directly and have the certificates already on the device and already on NSO. So that's what the yellow boxes says here, that we can use the certificate to verify the device, and the device can use the certificate to verify NSO.
So I have a question. I'm not. Hi.
No,
Here am I.
sure.
Maybe you're getting to that. So feel free to defer this. But so I'm curious about the NSO PMP server. Is this something that is actually in NSO? I mean, do you actually have code that's like call back something from a built-in web server inside NSO, or like? Yeah, how does?
So it's a function pack. So that's a package, basically, if you know the NSO terminology. So it's a package you put in the package directory, which will hook into the web server of NSO, and then use the APIs that the MAPI APIs or CDB APIs to talk to NSO. But it's from one perspective. If you have NSO with this package, it's one unit.
No, right. Yeah, I was interested in the actual implementation. Like, I wasn't. I mean, I'm aware of all the other normal kind of callbacks, but I wasn't aware that you could actually hook into a web server inside NSO and modify or return data
you
on
can.
this level. Okay, nice.
Might not be documented, but it's you can. Right. So that's the HTTPS. That's actually not PMP really. That's just the regular HTTPS security.
All right, we got one question.
Sure.
All right, so right now, I guess this just supports Cisco devices that have PMP agent enabled.
Well, it supports any device that speaks PMP, but that's as far as I know, only Cisco devices.
Well, I guess what I'm wondering is obviously if this is a function pack that's embedded in NSO, etc. Like at my previous life, I actually implemented this, but using just regular boot P, TFTP, same options. DHCP, etc. But we had a cron job listening, and we had a workflow element that would then kick off the call to NSO directly for going in and taking care of the device, right? Obviously, this will add some extra security for communicating with the device, but can we use an external thing for multi-vendor support, kind of as a proxy? Because not everybody is going to support PMP.
Yeah, but you can, but then you would go outside of what we support.
Okay.
So I mean, yeah. But if you have something that speaks with something, then speaks PMP with us, that's sure. That's up to you. Or.
So I was just going to say we did some work with Juniper's equivalent. I think they call it call home or something like that, but they have a server, and we actually did a little bit of thing where we added support for an action, so they could configure their server to call ours when they onboarded a device, and it would pass to NSO some of the same enough information that you could onboard the device. So that's one example where we integrated with. What's that? They have their own standalone PMP server, and you can configure that to call into NSO when it onboarded a device.
You're right, but it's nothing we support out of the box.
No, but it kind of gets you where you want to go.
Sure. Yeah. You can with NSO you can do anything. Okay. So in this slide you'll see what's called SUDI, and that's the security on the PMP level. So what happens if you skip the two first lines, you will see that the device, we have marked the device we have marked in NSO that we require SUDI authentication. So what that means is that we will send a challenge, a cryptated challenge to the PMP agent, which it needs to respond to, and we will validate that response. So then the PMP agent uses some Cisco signed certificates, which we also have the public key for, so we can send something to them, and then they will answer something, and we can decrypt that and see if this is actually a proper PMP device that has the Cisco certificates approval. And then everything happens as normal. After we've done the SUDI challenge, we will also have in the back and forth communication, we will also have a SUDI ID that we will use to make sure that this is still the same device. A bunch of supported devices that I can't really say anything about other than these are a handful of devices that supports Cisco PMP today. And now a demo. Fredrik, how do I get to a terminal or something? Can I switch? Can I use this? Hello? Hello? Oh. I'll switch. Okay, so I'll start. This is actually the first time I use this ENCS, so I might fail. So this is the graphical user face of the ENCF.
NFVIS.
NFVIS. The ENCS is the actual box.
Yep.
Okay. And somewhere here I'll see the PMP configuration. Here, I hope. Where. Okay, yeah. So we have a PMP agent. We have pointed it to a PMP server and a port. So that means, or that should mean, at least that this box is now trying to, or is contacting NSO over and over again, but it's not configured on NSO yet, so we should just tell it to back off all the time. It should be in our unclaimed list. So if I do a, am I in the CLI? No. Oh. So first I'll just look at the operational data for PMP. And I see that I have one device here. That's the serial for the device. And that's the NFVIS that's contacting us. That's the serial of the NFVIS. So we see that it's trying to contact us, and we're just not taking responsibility for it yet. We just tell it to back off. Should I show the configuration? Or just okay. Show. Is that all? Is that all we did?
Yep.
Okay. So this is the configuration that will add this serial to our PMP map, so that we can claim it when it contacts us again. So I'll commit here, and what should happen now is that soon we'll see this device in our PMP list. So we see now that it's contacted us and we configured it. That means that we send it day 0 configuration. It has not yet responded to that, so in the next iteration when it contacts us again, we will add it and sync it. So that might have already have happened. Yeah. So that means that we should have a device as well now that wasn't there before. And that's that device, demo UCSC. It wasn't there before, even though I didn't show you that. Sure. Empty. Pew. Okay, I'll hand over to Fredrik.
So,
Sorry, question.
So do we have any numbers that how many devices we support using a PMP function pack? So like one of my customer in Japan are targeted to use PMP for more than 1,000 devices, and I know not all devices gonna use PMP at the same time, but if there is any numbers that you already have tested, I would like to know that.
Well, so 1,000 devices are fine. I mean, this isn't the bottleneck. So if NSO can manage 50,000 devices, we can manage 50,000 PMP devices. Okay, as long as you put the fallback, so the back-off time when we tell the device to back off, apparently don't have a too short of an interval there. Yeah, by default it's 2 minutes. Prolong that. But otherwise, I don't see any issues. I personally can't point to any test results where we use 50,000 devices, but I can never do that, so that's... Okay.
Okay, so I'll talk a bit about the NFVO stuff, our function pack, the NFV orchestrator function pack. We have 2 incarnations of this, one for OpenStack sitting on top of the Elastic Services Controller, another Cisco product, a VNF manager built by our sister team in Ottawa. Then we have the NFVO for the NFVIS, which we're going to use here today to demo. And it's a fully supported function pack from the BU. Just quickly how it fits into Etsy. Anyone here who heard about Etsy and the NFV stuff, the Mano? So Etsy is putting out documentation, and this image actually comes from them, and it kind of shows how we map into that image with NSO, and in this case, it's the Elastic Services Controller. You could imagine this being NFVIS and this being ENCS to make the comparison. So the reason it says day 0 there, so if you take NSO with the NFVO function pack, you kind of get day 0. You can spin up virtual machines and you can give them day 0 configuration. And you can stop there if you like. You can, and then you could hand them off to someone else or to an operator to do manual configuration of the VNFs. What's really cool though is if you actually use NSO, you can bring the devices the same way we did with PMP, add it to NSO. You can do the same thing when you boot up your CSR1 KV. You can add it to your device list and actually configure it. So you can write a service that instructs OpenStack or NFVIS to fire up a virtual machine, and when it comes up, you can actually program that device. So some terms, a VNF descriptor. It's a VNF descriptor describes a VNF in itself. That could be a single VM VNF. If you take a Cisco ASA, for example, that is a single VM. It's a router. If you take the virtual packet core, that is like a 3 different kind of VNFs. So the VNF descriptor describes the structure. So in the packet core, for example, it defines how these VMs fit together with the networking. You point out the requirements. So the CSR, for example, you're going to say that it's going to need 4 vCPUs and, I don't know, 3 gigs of memory, 30 gigs of storage. The packet core, you say that the control plane needs this, and so forth. The requirements for being able to start this VM. And it defines the structure. I have an image coming up. One thing that is important to remember, because I'm going to talk about network service descriptors later on, and the difference between the VNFs and the network services is that these are supposed to be immutable, meaning if you buy a VNF from F5, they should provide the VNF descriptor. and you shouldn't modify it. If you buy our ASA, we should provide the VNF descriptor for that, describing how it, what it looks like. And then, yeah, I'll get into the network service. But bear in mind that immutability. So this is, as I said, a simple one. Single router defines some external connection points. This is a more complex VNF descriptor, looking like the packet core, which has some internal networking, it has some external connection points, and it describes the structure of this guy, what it will look like if you fire it up. Yes. So in this case, you actually have two control planes, hot standby setup, and the actual service plane. And if you look at this guy, you can keep those two and you can scale this in and out. I don't remember the figures, but it's I don't know, many VMs described by the same VNF descriptor.
How does that go together with immutability?
So, yeah.
You said you could scale it. How does that go together with immutability?
So when I say it's immutable, I mean it's immutable that it's the way the structure of it is prescribed by the vendor creating this.
The descriptor, you cannot change the descriptor.
Exactly. But this descriptor could say that, if you want to go really advanced, it could say that with two control planes, functions running up there, you're allowed to scale this from 1 to 10. If you want to go to 11 from that, you're going to have to scale out the control planes as well. All that can be encapsulated in the descriptor. So, and again, what I mean is, it's not that these guys can't go in and out. It means that if you buy this from someone, you shouldn't change it. The VNF descriptor should be something that you use to stamp out functions in your network.
Right, but it does allow some parameters.
Oh yeah, absolutely.
Yeah. Okay.
Absolutely. So if you want to take these and actually build something, so let's say you want to take an F5 load balancer and pair it with an Palo Alto firewall, or a Cisco CSR and pair it with the Cisco ASA, you will not modify the VNF descriptors. You will build a network service descriptor, or you will create one of those to actually take these functions and further build out it's a higher abstraction model. And what I mean by user is, this is actually something that you as a buyer, you build these functions, and that is described in the network service descriptor. And they could be multi-vendor, of course, so you could pair different ones. And again, they add structure to like this. So this is, even though it looks a bit strange, this is one network service descriptor, the entire thing. They can have what's called deployment flavors. So this guy actually have two deployment flavors. The one could be called router only. So you can take this descriptor and say instantiate it with the router only deployment flavor, meaning we would only start up that guy. But if you install it with a firewall and router deployment flavor, you will have to supply some more parameters, but we will actually start up the firewall, the router, and build up the network. Make sense? Maybe. So, turns out that we needed something. With all this documentation from Etsy, it's a lot of, you talk about it, we want to talk about it, and one really good thing with all this documentation is that we actually have a common vocabulary now. So if I talk to someone who has read this documentation and I say a VNF descriptor or a NS info or whatever have you, we actually have a common language now to talk about this. The next step would be, that would be real nice if we could actually have a common data model. We are of course leaning heavily towards Yang, so we have modeled all these documents, or many of the documents, in Yang. And that's what I mean when I say we are Etsy aligned. How are we on time? It gives a high abstraction layer. It turns out that in programming in NSO with asynchronous systems is a bit challenging. And we have the reactive fast map as an answer to that. But it actually, when you're talking to ESC or NFVIS, for example, you're actually going to get events back, netconf notifications. So that is one of the things we do in NFVO, is we're hiding all that from you as a user, and you can treat this as using your normal reactive fast map programming. We are good on time. So this is actually what it looks like when you interact with ESC or NFVIS. So you're going to send some configuration down to that device. We will see that later on. What will happen is that it will start working and send us notifications, netconf notifications back. So we'll get one, for example, saying VM deployed, meaning that the hypervisor has accepted the deployment. It's not started yet, but it's there, and the networking is in place. The next thing that's going to happen within minutes or seconds, depending on the VM, is we're going to get a VM alive. So you can, for example, set up to check if it's alive, do a simple ping on one of the interfaces, and if that is good, you consider it to be alive. If you have more complex VNFs, you may have to set up a script that actually maybe logs into the VM and make sure it's good. But when we get the VM alive back, the device should be in a state where we can actually configure it in NSO. So what we're going to do is we're going to add it to the device list. We're going to fetch SSH keys if it's such a device, and we're going to do a sync from. And when all the VMs in a VNF are up and running, we actually get a service alive, which means we're going to update the state, update the plan, as we call it, which means that a service north of us, someone started booting these VMs for a reason. We can actually trigger them, typically through kickers, saying that all the VMs you asked for are now up and running. And that is what I mean with updating the plan. We set a flag, basically, saying that we are now up and running. Any questions so far? Otherwise, it's back to the demo. Great. So before we begin, let me show you what a VNFD might look like. I'm going to take this VBranch ISR, for example. So this is what it looks like in NSO. You can see it describes can you hear me? Maybe I should use this. Describes the image. Where can I get the image? Download it from somewhere. And we'll actually use this soon, because this is just information in NSO at this moment. But since we're going to boot this guy in the NFVIS, we're actually going to onboard this into NFVIS. So we'll actually download the image from there. You can see that we describe the connection points. Since we're going to manage this guy, we tell it what kind of NED to use. So this is an iOS. You can specify which day0 files it has. I won't dwell too much on this, but this is what it looks like from a very high level. You define your image, your requirements, CPU, memory, and so forth. Yeah. So what I'm going to do now with my, let's see, switch back to this. So I have my NFVIS running. I have, let's see, show full configuration. What's it called? Demo USC. So this is device this is the NFVIS itself. And what I'm going to do now is I'm going to start off telling it to onboard the ISR image to make it usable. And the way I do that is I'm going to use the VBranch function pack. So I use branch CPE. So this is my guy. I'm going to tell it that I want to use the VNFD, the ISR, and the ISRV small. So I'll commit this and just tell you what I did. So what I'm instructing the NFVIS now to go and fetch that image for that ISRV small. So if I switch back into here now, we should see it's created the flavor, and it should be downloading the image. So if we give it a few seconds, I'm kind of hoping to get the image here soon. If I don't, the rest of the demo is screwed.
So basically, you're using the VBranch is using NFVO, right?
Yes, yes.
The NFVO functionality.
Good point, good point. So VBranch, so we have this layers of function packs. So VBranch is sitting on top of the NFVO function pack and utilizing that to do what I'm showing here. So now it has actually downloaded the image. So now I have onboarded the images to my NFVIS, so I have it in a state when I'm actually ready to use the ISR image. So the next step is to load a small deployment. So what this says is so let me, before I'm jumping ahead here. So let's take a look at this. So the next thing I'm going to do now is I'm going to set up a router. Going to set up a router between the WAN net and the LAN net. And the way I do that in the VBranch function pack is, so I'm saying I'm going to create a router. This is just an arbitrary name, but I want to use the ISRV and the small version. I'm binding its network interfaces, the first one to the WAN net, second one to the LAN network.
Assuming those networks are already present.
Yes, they are present here. So we could actually, if we have some time. So let's do this. See if we can create the network. So I'm going to create a new network, test net. And then I'm going to do, so instead of binding it to the LAN network, I'm actually going to bind it to this guy.
Changing the demo, mid-demo.
Oh, yeah. See if it works. The VDU, what am I doing? VNF, router, network, test net. What am I doing? Oh, I'm going to remove LAN net. Test net, NIC ID 2. So let's see if it works. So I'm going to create a new network called testnet. And where is it? Yeah, there it is. Let's see if it works. So it actually created the network. I can see that in here. If I reload this. So, oh, okay. Here we go. Woo! Woo! So what is happening, you can see up there the VM deployed. So we actually got the message back to NSO now that the VM has been deployed. This guy takes a few minutes to boot. But we know that it deployed okay, meaning that the compute had enough vCPUs and memory and storage and all that to facilitate it. And if we give it a few minutes, we will actually see it in NSO. Oh, there it is, the demo router. So you can see that it actually has the same IP address as the NFVIS itself. The reason is that since it's running in there and it's supposed to be at a customer site, what we do is actually set up port forwarding. So I can check out where it is, but we actually forward a port for this guy into the SSH port, basically. So let's see if it's running. Show. Yeah, here it is. So this is the ISR up and running. And at this point, I could actually have a service that started configuring this for whatever network service I was trying to build with this. That is actually all I had. Any questions?
Sorry, the question was if this is, let's say, a default empty configuration, or did it do a sync from?
Oh, maybe you're right. Maybe it's, yeah,
Okay,
now it's synced
next
from.
time. That's better.
I was a bit too, good question.
Thank you.
Okay. Thank you. Thank you.